Review for test 5. Find the 115th term of the sequence 2, 7, 12, 17, and so on. If you were to find what this goes by, from 2 to 7 you add 5, 7 to 12 plus 5, 12 to 17 plus 5. So we know that the common difference, or the slope, rate of change, is 5, and we know fx equals f1 plus mx minus 1. So we want to find the 115th term. The first term, the output, the first term is 2. That's our f of 1. The output at 1 is 2. It's adding 5 repeatedly, and I want the 115th term. If I find out what 2 plus 5 times 15 minus 1 is, I get 572. So that is the output of the 115th term of the sequence. Find the 35th term of the sequence. Same idea. I want the 35th term of this sequence. Here we got 3 to 7, 11, 15. This is adding 4. So the output of the first term, right, f1, output of the first term is 3. It's adding 4. I want the 35th term, so I plug that in for x. And if we find out the output of that, it is 139. The 5th term is 35th term is 139. Hector wants to get his grades up. He starts by studying 15 minutes on the first day, then adds 5 minutes on each day. Write the explicit and recursive form of this situation. He studies 15 minutes on the first day. That's the same as saying f1 is 15. Adds 5 minutes each day. That's our rate of change, or our slope. We can write this in more than one way, but if I start with explicit, I'm going to start with explicit. So the output of the first term, we got 15. It's repeatedly adding 5 every month, and I just put x minus 1. If I want the recursive, I have the previous term, and we're adding 5 to the previous term. The second way I could do this is writing a sub n, and it would look very, very similar to what I had, only the n would be switched with the x. But it doesn't matter what variable you use, so both of these work. So a sub n, in this one, this is our previous term. We write it a sub n minus 1. That's our previous term, and we're adding 5 to it. So either way we go, whether we write it fx or a sub n. We're going to do the same thing with this next one. Costco decided he was going to save pennies. He started saving 15 the first day. He doubles this amount from the previous day. Write the explicit and recursive forms of the situation. So we know we are working with doubling, which is multiplying by 2. So we are writing out our explicit of an exponential. So I still put my f1, but then I times it by r to the exponent x minus 1. So f of 1, the output of the first day, is 15. I'm doubling, timesing by 2 to the exponent x minus 1. Then for recursive, I am multiplying by 2, and we're going to put that first. I times 2 to the previous term. And that's how I write it, 2 to the previous term. If I want a sub n, for this same problem, it would look very similar. I would do 15 times 2 to the n minus 1. And if I want recursive, 2 times a sub n minus 1. Both of those ways of writing it are correct. Okay, next problem, number 5. Consider the function f(x) equals 4 times 3 to the x. Create a situation that would model this function. So we know on the first day or first month, whatever it's talking about, I'm going to say on the first day, oh, this isn't the first day because it doesn't have x minus 1. My bad. At the beginning, 4 people are sick. Each day, they spread their sickness to 3 people, to 3 other people. So if the sick people are spreading it to 3 other people every day, then that's multiplying by 3. I have to erase this part so I can write these next ones. Consider 5x plus 2. Create a situation. You pay $2 to get in to the parking garage. And every hour, each hour you pay $5. So that's adding 5. All right, find the recursive and explicit forms for the following table. Well, the table is multiplying by 4 repeatedly. Got to make sure it's doing it the whole entire time. And notice we have a sub n and n here, so I got to do a sub n. I'm going to do explicit first. The first output number is 5. We know we're multiplying by 4. Repeated multiplying is exponent n minus 1, because the first term is 5. Recursive a sub n equals, we're repeatedly multiplying the 4, so I'm going to put that first, to the previous term. So we write a sub n minus 1, the previous term. Next, you are going to take out a loan for $800 with simple interest. Simple interest, I'm going to write it out. I equals PRT. You pay the full amount due after 1 year. What is the total amount owed to the lender after 1 year? The interest we're going to pay would be $800 is our principal times the rate. Remember, the rate has to be a decimal. So you can divide it by 100 to get the decimal. That's 0.082. And time is 1 year. If you multiply that out, you get $65.60. So that's the interest, but that is not the question. The question says, what's the total amount owed to the lender? Therefore, we have to pay the $800 and the $65.60. So the actual answer to this question is $865.60. That is how much you would owe to the lender. Number 9, how much do you make if you have $1,400 invested at 9% compounded monthly over 3 years. Remember, compounding is the formula for compounding is A equals P, 1 plus R to the T. So on this one, it's going to be, we got A, the amount that you are going to pay is $1,400 is our principal. 1 plus 9% as a decimal, so divide 100 is 0.09 to the power of not just 3 because it's compounded every month. So how many times that would be for 3 years? Well, 12 months the first year, 12 makes 36. So this is 36 as your exponent, which means that you end up paying $31,000, $151.72. That's a huge amount of money, especially. It does say how much do you make, so that's an awesome investment. 9% is a huge amount of money. Okay, number 10. A car costs $12,500 and decreases in value at a rate of 2.6%. Assuming the rate of decrease remains the same, which equation represents how much your car... Nope, I'm reading number 12, sorry. Number 10. A car costs $12,000, decreases 6%. How much will it be worth after 4 years? So we're using this here, right? Compounding. But remember, we got a plus or a minus on there. Because if we're decreasing, it's going to be the amount is going to be 12,500. 1 minus decrease. 6% as a decimal is 0.06 to the exponent of 4. So the car will be worth an amount of $9,759.36. Number 11, you get charged. You get a charge card with $4,000 limit. In the first month of getting the card, you spend $850. The charge card charges 12.5% compounded monthly. You don't make any payments for 6 months. What do you owe on the charge card? It does have that limit, but we just care about how much you spend because they charge you interest on the money that you spent. So the amount of money is principal. We spent $850. 1 plus, it's 12.5% as a decimal, which is 0.125, and compounded monthly for 6 months. So I would just have the exponent of 6 because it's just 6 months. It's not for a year, it's not for 2 years, 6 months. And if I find out that amount of money that I would end up paying after 6 months is $1,723.19. Charge cards are expensive if you are not paying them off right away. Okay, your first car is $6,500, depreciates in value at a rate of 2.6%. Assuming the rate of decrease remains the same. So we do know that we have our money amount, the amount that the car is worth. 1, it's decreasing at a rate of 2.6%. So that as a decimal is 0.026. And we want it for 4 years. So we're going to match it up with the equation that goes with this.